Okay, first thing before we continue, first thing I would like to announce is that after the chapter 9, we actually have a midterm exam. Okay. In the course share, there will be a midterm exam, and this one we will know how good you are. So it is a half set AP exam format. Okay, so regular AP exam had 40 multiple choice question, 4 FRQ. So this one is 20 multiple choice and the 2 FRQ format. Okay. So we have a midterm exam. Please welcome it. Let me check. Okay, I actually forget it. Maybe full set. Let me check. Okay, yeah, it's actually a half set. Probably even shorter. Okay, it's okay. Please work on it. Okay, work on this midterm. And then we actually will start the second half. Second half is starting from for this unit 3. We are going to start unit 3 this week. Okay. So what happened is we have unit 1. Unit 1 is on the data and expression. So it's basically on tokens. Tokens is single variable x, a number 3.4. Okay, that actually is the unit 1 we basic on it. Second 2 is in selection and iteration. So second 2 we work on if then else, for loop, while loop. Okay, this we call it program structure. So unit 1 is actually on x plus y, the single word or a expression. And then unit 2, we are talking about the program structure. Okay, so program structure including the if then else, the selection, and also iteration using the for loop, while loop. Okay. And sometimes some book textbook, this chapter measure is also considered to be the unit 2 for the program structure. But right here, in the new AP curriculum by the College Board, they separate this measure to the unit 3. So unit 3 is on class design. Okay, but anyway, this is still, you can consider it's still part of program structure and part of the class design. Okay. So we'll go into the second half, and second half, unit 3 is on class. On class. Unit 4 is on data collection. It's actually like data structure. So these two are already going to the data centric. The first 2 units are program centric. We talk about program structure, program centric. And now we go into the data centric. Data centric means that every day we're talking about data. Okay. And then program centric actually is primarily on program and program structure. Okay. So that's what we are right now. And please work on the midterm exam. Okay. Please work on it. This is due next week as well. So this week you will have chapter 10 due and also midterm due. Okay. Please work on it. More work to do. Okay, that's the first thing I would like to announce. Second, we will get started for this chapter 10. So chapter 10 is on method and testing. It's actually another program structure. So regularly, our program structure that we talk about has the selection. And selection based on the condition, you actually take different branches. So you may have a condition and then you select yes or no to select different branches to run, okay? Or you actually go by a for loop. There's a condition you test, and then you go into doing something, and you update some variable, and you may repeat or get out. Okay, that's actually iteration. And another one is that you go to a sub-function, and you jump to the sub-function, and then run the sub-function, and then return. Okay, so that's what we would talk about today. This is a third program structure that we call it sub routine. Okay, we call it subroutine. So this is three in combination. We call it structural programming. Okay, structured programming. Let me pause it. Okay, this chart for you to take a note. Okay, this we call it structured programming. So we already talked about the selection and iteration. Okay, iteration is by loop. Now we're talking about third one, it's called subroutine. Okay, subroutine is that you have a main program and then you finish it and you go to the subroutine. And subroutine sometimes it is named as procedure. Sometimes some people call it function. Sometimes some people call it subroutine. Sometimes people call it code segment. Sometimes some people call it method. Sometimes some people call it what else the name? Subprogram. Okay, these are actually almost the same. These different names are almost the same. Okay, they actually mean the same thing. Procedure, function, subroutine, code segment, method, subprogram. They actually mean the same thing. It's just saying that there is a smaller program that you would go into, and then you will run it. Okay. So it just means that you go and then you go into a subprogram and you go to the program and you run it. And when you finish, you come back to the original main routine. So this one we call it main routine. This one we call it subroutine. So main routine, main function. Okay, routine is what? Routine is step by step. Step 1, step 2, step 3, step 4, like actually certain routine. You wake up in the morning, 7 o'clock in the morning, you go to bathroom to clean up your teeth, and then you actually dress up and then you go to school, and then you take the bus, and then you actually take the classes, and then you finish it, you go to the cafeteria, have lunch, and then come back home. Something like that, step by step, we call it routine work, okay? So subroutine is a routine, but it's a smaller one. It's not a main one, so we call it subroutine, okay? So subprogram is similar. You have a main program, and then you have a subprogram, okay? So these two are similar. So sometimes your subroutine have return value. You carry the value back. Sometimes you don't. So for those one that carry some value back, we call it a function. So you have y equals f of x that actually is a function. Okay, so a subroutine with return value, we also call it a function. But sometimes there is no return value, so it's a void type. Void type function, we call it a procedure. But sometimes a procedure may also have the return value, but sometimes they don't. Okay, so in some language like Pascal, Pascal, Pascal language. In Pascal language, procedure and the function are two different things. Procedure means that there is no return value. We call it procedure. A function is a function with return value. So these two actually sometimes has different meaning, but most of the language procedure and function are the same as well. Okay. And code segment is the subroutine in COBOL language. There's a language called COBOL, COBOL. Okay, COBOL language, Common Business Oriented Language. That's called COBOL. So COBOL language, they call it code segment. Okay. And then object-oriented programming language, the function we call it method. So Java, in a way, Java is object-oriented programming language. So Java's function usually is called a method. That's why in most of the textbook, you will see this word method. Method is a function. Method is a function defined in object-oriented programming environment. Okay. Any questions so far?
No.
No. So these are the basic definition of the function subroutines. Okay. Now, next one is why we need the function or methods. So first one is modularity. Okay, modularity. We want to have the modular design. Or sometimes we call it black box design. Okay, black box design means that we actually have a program unit. Okay, and then this is actually a function f of x. We do care about what you get put it as an input. Okay, and you care about what is the output. As for the inside, we don't really care, so we call it a black box. So inside, actually, what it did, we actually not really care. Okay, that's why we call it black box design. Okay, so that actually is the need for function. And then you would like to make the code reusable. Okay, make the code reusable. That's the second purpose of using a function. Okay, make the code reusable. Third is more structured. And it's easier for debug. Okay, easier for debugging. Okay, these are the purpose of having a function. Okay, now let's look at different things now. So actually, when we do the coding back, so when we do the coding back, whatever function you pick, okay. So whatever function you pick, actually this one you do go and then it's wrong, right? So basically, this one, when you get started, they want you to write a function. Okay, this one is a function, and this actually is a static function. Okay, and then when you test it, you actually use different test vectors. So what is text vector? These are text vectors. These different value are text vectors. You pump a different text vector to the function, and you are checking whether the result is the same as expected or not. If it's the same, then it mark correct, okay. If it's not, then you actually will respond what's wrong. So basically, this one is a black box testing. They give you the different test vector and then collecting the result to compare whether the result is expected or not. Okay, so this one, the whole Java coding bed is a writing function activity. Okay. So that's very important. So you actually learn programming pretty much based on a lot of methods and testing. Methods and testing. That's the main activity that you go through for coding bed. Okay. Okay.
Yeah.
So we talk about in this chapter, we talk about the basic features of the functions, and we talk about class functions and instance function. We'll talk about how to call method, what's the parameter, what's the return value, and what is activation records. Okay, these are different terminology you need to learn. We also will talk about procedural abstraction, overloading. So first, let's look at function. Okay, function. So function are self-contained module of code that accomplish a specific task. So function take in data, process it, and return with a result. Once a function is written, it can be used over and over again. So functions are called from the inside of other functions. So one function call another function. That's what it means. So basically, let's work on some functions. So first one is a main program. Main function is a function as well. It's just a function. It's the first function that you write for a program, right? This actually is a function. Now you may call another function. So let's do it public, okay, and then static square integer n, okay. This one is a function, and you will return n times n, okay. So this one is a static function. You will return a integer with the value of n times n. So it's the same as a function that is square of x, and you return the value. That value that's as soon as y. So it actually is a mathematical function with the input and with the output. The output is the square of the x. Okay, something wrong with this text. Okay, anyway, so okay, this one I think everybody know. I just wrong it. Okay. So this we call it a function. Function is a procedure with return value. Okay, right here you do have a return. Second one, you may have a function without return value. So you have a public static void, okay, with n, okay. So you do have an input value n, but you just would like to print it. So you wrongly say that's wrong print n for 3. Okay, that actually is a function without return value. So you if there is no return value, you put a void over there. Okay, so here actually you actually have a void over there. Okay. Now sometimes you may have a so you may have a function that's called print 3. Okay. So you do print 3. Okay, we'll get to Java. This one will run the this print line of the message for 3 times. So it actually is a function that do repetition. So you can actually reuse it to do a same thing for many times. Okay, this one is actually also a void function. Okay, no return function with no return. So here we do have a function with return value and function without return value. So function without return value, if right here you write return and with no value, this is still legal. This is still legal. It just return no value. It's return void as well. Okay, so that one you write the return or no return essentially means the same thing. The program will terminate. So this one is legal. Second, it means that return also means another thing. Also means the keyboard is crazy today. Also means the end of the function. Okay. You terminate the function as well. Okay, you write it or you don't write it is the same. If you write it with some value, that value will be carried back to your program. Okay, your program. So right here, if you call the square function, and then you do call the square function, and you call square 9. And you call square 9, but you do not have a variable to assign it to. So you do not have this one. You do not have the integer y equals this. You do not have that. So it actually it do has the return value, but it will be dumped. Okay, it do return a value, but that value 9 square will be dumped. No one will use it. Okay, no one will use it. Okay, so some function has no return value. Some function has return value. If the return value nobody take care of it, then it will be dumped. No one will use it. Okay. And if there is no return value, but you do return, that actually will not return any value back to the main function. It will just means that it's the end of the function. Okay, these are the basic idea. Any questions so far?
No.
No. Okay, these are the definition for functions and basic idea, okay? So we do want to reuse the code. So here are the different steps of writing a function. First, you need to understand the purpose of the function, okay? So for example, the square function, you want to create a square of a number. So that's the purpose. Usually one function, you just assign one purpose. Do not assign too many purpose to the functions, okay? So usually one function, one purpose. While you are doing it, you just put a single purpose on it. And function is a little bit like a paragraph. Just like paragraph in English. One paragraph is one topic. Okay, one topic. You don't put too many topic in one paragraph. Then your paragraph will be too much loaded. Okay. So right here, same thing. One function usually have one purpose. You need to tell people what is the purpose of this function. So usually you see our function name maybe is palindrome, right? Palindrome. It's just to check whether the string is a palindrome or not. Has even, whether it has an even function or not, okay? Okay, or get x, okay, get the x function. So these are usually the purpose of the function. You just have a single purpose assigned to the function, and usually your name should be named as close to the purpose as much as possible, okay? And then you define the data come into the function that we call it parameters. The data that go into the function, we call it parameters. Sometimes we also call it arguments. Okay. Okay, and then the function will process the data, and then eventually you will actually provide the result, and that would be the result is the return value. Okay. And then you have the input that's parameter, output that's return value, and then you based on the text vector and the return value. Okay, return value. You check whether they are the same as expected or not. That's for the method testing. Okay. Okay, this part I think is okay. Then next one you need to know about lifetime and scope of variable. When you define a variable, where the variable will be available. Okay, these are the lifetime and the scope. This one we'll discuss it later. Okay. Okay, next one is a function, parameter, and actual parameter. Let's look at the function. So here you have a main function, and your main function to integer the pass integer of the argument I, okay, and then you get the integer argument. And then this argument is a parameter being passed to the harmonic function. Okay. And then the harmonic function calculated to get a sum. Okay, this one actually is 1.0 over 1 plus 1.0 over 2.2 over 2. Let me see. 1 over 2 plus 3 over 3. 1 over 3 plus 4 over 4. 1 over 4. I'm sorry, I keep repeating the error. We do it again. It actually is 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 up to 1 over n. This is called harmonic. Okay, harmonic. So the harmonic calculate the harmonic value and return. So this purpose is to calculate the sum of the harmonic series. Okay, and then you get a return. So this one called parameter, this one called return value. Okay, now scope of the variable. So let's look at a few variables. So when you have a variable that's called arguments, so this argument is a parameter. So this parameter would be alive. So you come into life starting from here, and then it will be done over here. So the lifetime for this argument is from the beginning of the function to the end of the function. It's called the scope. Okay, scope is the lifetime of the variable. So the lifetime of this argument is from the function being called to the end of the function. We call it the lifetime of these arguments. Okay. Any questions so far? Any questions so far?
No.
No.
Next one is I variable. I variable, the lifetime is the starting of the for loop. And then your I equals 0. And you come back to change to I equals 1. One more iteration. So keep doing that until I equals argument that length. So the whole thing, many iteration, this is the lifetime for I. But out of the for loop, the I disappeared already, no longer valid. Is that okay?
Yeah.
So this one, we call it functional level, local variable, functional level. Is the lifetime is the whole function. This one we call it loop variable. It actually the lifetime is the whole loop. Okay. Next one, when you have this argument ARG only live when it is declared until the end of the iteration. So when I equals 0, there is one argument, and it only live when I equals 0. When I equals 1, there is a new argument. This argument and this are different one. These are not the same one. So this is per iteration variable. So I is many iteration. This integer argument is single iteration variable. Okay. So right here, this one is also functional level variables. This one is functional value variable. It's actually from the declaration to the end of the function. Okay. This one is a loop variable. It actually is during the lifetime of for loop, the I will be available. These are the different scope of the variable. Okay. Any questions so far? Okay. So that is the lifetime and scope of the variables. Okay. Sure. So next one we'll talk about method. Okay. Function and method are the same thing. You said that method is the term for object-oriented programming languages such as Java. Okay. So you have a code that actually do this, taking the sum from 1 to 10, this one from 20 to 37, this one from 35 to 49. So the code is almost the same. So you actually can parameterize the code and then make it as a sum function from integer 1 to integer 2 and put a for loop over here. So the previous code can be summarized as the 3 different function code. So this one, number 1, you do parameterization of the parameters. Second, you actually make the code reusable. Okay. So originally you code so many lines. Now you actually make them 3 function code. Okay, 3 function code. So that make the code reusable. Okay. So now we can have a definition for the method. You have a public static integer max integer num1 num2. Integer num1 num2 we call it parameters, or sometimes we call it formal parameter. Formal is actually official, means a more formal, more it's actually it's more systematic way. Okay, we call it formal parameter. So when you say maximum of the 3 and 4, these two we call it actual parameter. X, Y, or num1, num2 is the formal parameter, while the value that you put into is actual parameter. We also call it arguments. Okay, this is the name. And then maximum is your function name. Max is the function name. Okay. So when we talk about the signature of the function, we actually talk about from the name to the parameter. This we call it method signature. This one very important. Okay, you must remember what is method signature. Method signature means that a function with the same name and the same formal parameter type, we call it the same function. Okay, so signature means the ID, whether a function is the same function or not, depending on method signature. Okay, we'll cover this later. Okay, so this part is called method signature, and the parameter list is this part called parameter list. Okay, and then there is a return value. There is a storage class right here. It's called static. Static means it's a static function. It's a class function. Okay, and class function is a function defined in a class. Instant function is a function belonging to an instant object. Okay, this one we talked about it before, but right here just remember there is a static function and non-static function. Okay, and then public or private. This one means that whether other module can call it or not. Okay, this is public or private. So these are the whole method headers. Okay, method headers. Or sometimes we call it prototype. Okay, so now we call it prototype. Okay, so these are the method headers. And in the body is how you work on the numbers. So you get a num1 and num2, you compare who is bigger, and you will store it into the result. And then you will return the value for the result. Okay, so this is the definition of a method. So you can put maximum 3 and 4, and you will return 4. And that return value is the result that you get. Okay. So this is a define of a method. Okay. The next one is the calling of the function. So define of the function will not run. You have still need to call it. Okay. So the left-hand side is a mathematical function. You have a y equal f of x equals x squared plus x plus 1. X we call it dependent variable, independent variable over the domain. Y is the dependent variable over the field. Okay, it's a domain and field. X is domain, Y is field. Okay, and then Y equal f of 3. That's an example. So this one we call it call of the function. You call the function, you put some value in there, you get the result. This is actually running the function. So in Java, you define the function in this way. And then you call it in this way. If you don't call, the function will not be run. It's just the definition of the function, but it will not be run. You must run it. You must call it. Otherwise, it won't run. Okay. So right here, you have a main program, and then you have I equals 5, j equals 2. You call the maximum of I and j. So you basically pass your I, that's 5, to num1. You pass your j to your num2, that's actually 2. And then you compare the bigger one, so the num1 will be stored in result, so you have a 5. And then after you finish the function, you return the value to k, and you print out ijk, okay? So you start to have store I equals 5, j equals 2, and you pass the 2 and 5 to the maximum function, and then the 2 value being passed to num1 and num2, and then you actually declare a new variable called result, and then you compare num1 and num2, and then store the pick one to the result, and the result being returned to the main function, and k is the number to receive the result returned from maximum function, and then you print them out. Okay, that is the calling process of the function. Any questions so far?
No.
Okay, so far it should be easy. We just go through the definition of the functions. Okay. So next one, we have a sign of n. Okay, so here you have a n greater than 1, you return 1, n equals 0, you will return 0, n less than 0, you return -1. Okay, this one is actually a sign function. So here you have an extra if, but this one is not necessary. You can delete this one. Okay. And this else is also not needed. Okay. In fact, this else is also not needed. Okay. If you know how to simplify it. Okay. So you can reuse the function from other classes. Okay, whatever this one. Okay. Next one is activation record. Okay. Activation record, sometimes also call it call frame. Okay, so call frame, activation record frame, it actually is the way that your computer will process the function code. Okay, so what happened is, let's go back to the function code. Okay, so go back to here, go back to here. Okay, let's get started from here. So basically your memory, let's look at the memory, okay? So your main program, declare a variable I that equals 5. Declare a J that equals 2. Declare a K, but you don't have the value yet. Okay, this one is a call frame. That's called main function's call frame. You store these 3 variables. At this moment, K no value. Okay. And then you actually call the function, maximum function right here. And at that moment, you create a new call step. So this new call step would have 2 parameters. So that 2 parameter is called num1 and then num2. So you copy i's value to num1. You copy j's value to num2. Okay, and you compare num1 and num2's value, and you got a result. You got a result, and you actually will return. So when you return the result, so the result actually is 5. When you return the value, then this call frame will be destroyed, will be dumped. It will be cleaned up. And then you store the value of 5 over here. That's the K value that you got. Okay, and then you will print out this 3 value by the statement right here. And once your main function finished, the whole thing will also be erased. Return to the empty call step. So this one we call it, the whole thing we call it call step. It is used to buffer the local variables. So whatever variable that you actually declare in the function, say this one, this variable here, this variable here, these everything are put into the call step. If you have a static variable outside, so static integer a equals 3, it will not be stored in the call frame. It will be stored in the constant pool. That's a global data area. So while the class is valid, this a is always there. Okay. But this ijk only when main function is called, the ijk is available. If main function finish, then ijk will be cleaned up. It will no longer be there. So call variable is only for the local variable and only has the short lifetime for the variable. While static is always there. That's why you call it static, because the variable will never go away. That's static. When the class is available, your A is always alive. That's called static variable. Is that okay? Is that okay so far?
Yeah.
This is a very important idea of the activation frame, okay? Let's look at it. So here you declare I equals 5, you put the variable I equals 5 in the stack. Then you declare J equals 2, you put the J in the stack. Then you declare K variable but no value there, space required for the main function. So now next one, you call the main functions with the passing the 5 and 2 to the maximum function. So you create a new call frame and copy 2 to num2, 5 to num1. And then you create a new variable called result. And then you compare the data and then you get a assigned file to result. And then you return the result of the file back to A. And then you clean up the code frame for the maximum function because you no longer use it. And then you have an ijk and you print out by the sprint line function. Okay, that's the whole life cycle of this code step operation. Okay. Any questions so far?
No.
No? Okay, next one we are going to talk about void function. So void function is a function with no result, okay, with no return value. So this one is pretty simple, okay? So when you have a void function, sometimes we also call it procedure. Okay, procedure, just a pure procedure, is not function, okay, it's no return value. Sometimes we call it procedure. In some language like Pascal, the procedure and function are different. Okay, but not, I think in Ada as well. Okay, but in Java, there's no difference between these two. Okay, statistic functions. So this one calculate the sum, maximum, minimum. Okay, this one, okay, we don't demonstrate it in easy. And then we have call by value. Call by value means that your function pass the value to the function. So here you have the welcome to Java file. You pass the value to the function. This function called nPrintLine is a print line for n times. Print line for n times. So you do for loop for n time to print out the same message. Okay, it's called nPrintLine. Print out the line for n times. Okay. Any questions so far? Any questions so far?
No.
No. So this one, you have a welcome to Java file. You will print out welcome to Java file time. You have nPrint time, print line, computer science 15 time. Okay. But if you call the function by 15 and computer science, it will be wrong because you pass a number to string, a string to integer. That is, you have is input mismatch. You create mismatch of the input, and then the function will not be called. Okay. That will be a compiler error. Okay, so far these are simple, so we don't waste our time to do it, okay? Okay, next one is modularization of the code. You actually have a method header and you have a body, and this one we try to keep it as a black box. So every time you tell people what you can call, you can put as a function and parameter x, y. But inside there, how you compute, you don't need to take care of it. Yeah, people don't need to know. For example, you just calculate the square of x, but how square is being calculated, you don't need to tell people. That's actually called black box. Okay, black box. So you only care about input and output for the function. This we call it method abstraction. Okay, hiding the technical detail. It's called abstraction. So these different one we tested last time. Okay, it's okay. Converting hexadecimal to decimal. Okay. Okay, last time we converted decimal to hexadecimal. Now this time we would want to do hexadecimal to decimal. Okay. So hexadecimal is actually a string. Okay, that's a string is A, B, Y, E, F, something like that. We'll convert this one to a decimal value. Okay. So now let's do this in a function. Okay. Okay, so this function we call it hexadecimal to decimal. Okay. So this one to public static. Okay. The return type is integer, and we will do add to check. The input is a string because it's a hexadecimal string. Okay. Now let's look at it. So you will have a number. Let's assume it's called A, B, C. Let me clean up, okay? So C is the last one, you will time 1, B will times 16, A will times 16 squared. Okay, let's assume this actually is called base. So you let's call it H. Let's call it H equals 16. Okay. So this is 1, this is H, this is S squared. So the whole thing, the whole number you will want to convert is actually A times H squared plus B times H times 1. That is the sum you would collect and you will return. Okay, so this is the goal that you would like to do. So this is saying that AH squared plus BH plus 1 will be equal to AH plus B times H plus 1 will be equal to A times H plus B times H plus 1. Okay? And this tells us how the repetition will go. Each iteration, what you would do. Okay, this one actually is tell you how the repetition will go. Okay? So based on this, we are going to design our loop to calculate the sum of it. Okay? But basically, we are not going to use any of the conversion by the function itself. Okay, it is considered cheating if we just do integer that to string or value of that is cheating. Okay, we don't want you to do that. Okay, so now let's get started. So we will have a sum. At the end, we will return it. Okay, we will return it. Now we got a string of the S. So we are going to go through every single string. So it would be integer I equals 0, I less than S that length, I increase. Okay, so each time you get a character. So that's it. So that is character S. Okay, it is S that character at I. Okay. So this one actually create an integer d, okay, single digit. So this single digit will depending on actually this is character that is digit. Okay, check if the letter is a digit. If it is a digit, then you will pass the value directly. Okay, so you will do s minus 0. Okay, you will do x minus 0. That means that if you have if it is a digit, if the character is a digit, then you will have 9 minus 0. This is one character, this is one character, but you will return 9 for you. If you have 4 minus the character 0, you will actually return a 4. Okay? Is that okay so far? Hello? Is that okay so far?
Yeah.
If it is not a digit, then what we do? What we do is that if that's assume it actually, okay, let's assume that this one we only allow uppercase. Okay, so let's do this. Let's do s equal s that 2 uppercase. Okay, we don't want to deal with the lowercase, so you don't need to worry about the lowercase. So this s if it then we will do this one minus a. Okay, so x, if x, let me clean it up, something wrong. So if x is a later, you minus a, you get a 0. But a means 10, so you need to plus 10. Okay, so you get a 10. If you got a b, b minus a, you got 1, but you plus 10, you get 11. So this one, very easy, it will be x minus a plus 1. That will be the value of your digit. Okay, you got a digit, you got a sum, so your sum or plus equals your sum times 60 plus the digit. Okay, let's do this one more time. So you have, let's assume you have a by b. Okay, so first iteration, you get an a later. Okay, it converted to 10. Sum is 0. 0 times 16 is still 0. I'm sorry, this is not plus equal. This actually is equals this. Okay, it's not plus equal. So your 0 times 16 is still 0 plus d is 10. So your sum right now is equals 10. It actually is a only. Okay, it's a only. Now, second one, you actually convert this one to 5. Okay, so this one a will times 16. So it's actually a times h plus 5. That will be the end of the second round. Okay, third round, this one converted to 11. So it's this one times h plus b. That's the third round's result. Then that is the result you want to return. Okay, so this one is correct. Okay, this one is correct. Okay. So let's do average daily volume. So that's actually convert the FF, okay. FF is 255, okay. So that's actually convert the FF to decimal. Something wrong. I miss breakage. Something wrong. Okay. X minus 8. Oh, here's plus 10, not plus 1. Okay, I'm sorry. Typo. Okay. So this one is a algorithm to convert a hexadecimal to decimal. So number one, the purpose, there's only one purpose that you need to do. Second, you need to study the whole iteration to create a loop that can do it. So let's repeat again. You actually have a A5, B, you want to convert it from hexadecimal to decimal. So you start with the first iteration of this, second iteration, this one times the H plus 5, H is 16. Okay, so iteration is this times this plus 5 times H plus B. Then that is the result you want to have. This whole thing is A times H squared plus 5H plus B. Okay? Any questions so far?
No.
So first you need to know about the purpose. Second, based on the purpose, you need to design an algorithm that can solve it, okay? That can solve it. So this one hexadecimal to decimal just to show you how you can formulate a function that can solve the problem, okay? That is the one here. The GCD or prime number, we already talked about it, so I don't repeat it, okay? This randomized chapter, I talked about it before already, okay? I will talk about it later. Now, this one is the static versus instance level. Okay, don't talk about it yet, okay? That's this one, let me talk about it later. Let me talk about something else. Okay, I'm sorry, I should not close it. Wait. I make the same mistake again. Now, let me close it, okay? Let me close it. I make the same mistake again. I create a project on my desktop again. There's no good. So I forget to create chapter 10. Let me create a directory. Let me move this to the directory, okay? What happened? How come it doesn't work? One more time. Something wrong. Okay, I'm going to cover the homework, okay? I'm going to cover the homework later after this. Because I'm going to show you how to develop a function, okay? I'm sorry. The computer seems to be too slow right now. Okay, right here, select the folder. And this one is Okay, let's close the previous one. And now let's actually okay, move everything to here. Okay, good. Let me get started from here, okay? Okay, now I would like to cover the homework, okay? Which homework I'm talking about? I'm going to cover the chapter 9 homework. Some of you haven't returned the homework yet, okay? So please work on it. Okay, this one has two problems, okay? Both are very valuable problems. Let's look at this second one. It's actually exponential minus x squared. Okay, this one is a so-called Gaussian function. Okay, so basically this thing is equal to 1 minus x squared plus x fourths divided by 2 minus x 6 times divided by 6 plus whatever. Okay, so you will return this value and up to the n term. Okay, so this one you would be a ESP function with let's assume it's actually a double x up to the integer n terms. Okay, so this one we call it e to the minus x is equal to 1 minus x squared plus x fourths divided by 2 minus x 4 divided by 6. Okay, up to the n terms. The n term would be minus I raised to the power n times x 2n divided by n band. Okay, it will go forever to infinity because it's an infinite series, but we want to approximate it, so it's go to up to n. Okay, this thing sometimes we also call it Taylor's expansion. If you do calculus BC, they will teach you this Taylor's expansion, okay? But that's not what we want to do today. What we want to do today is teach you how to write a function to solve this problem, and also write a loop to process this, okay? Any questions so far?
No.
No? So first, let's actually get started with, let's call it Gaussian, okay? Okay, before we go there, let's actually look into the internet for Gaussian function. Okay, let's do this Gaussian distribution formula. Gaussian function, this one, okay? So this is the Gaussian function, this one. Is that okay? This is the Gaussian function. It do have, Wikipedia do have this. This is very important function, okay? So this one basically whatever not important. Here, no matter whatever value we put in, Gaussian distribution should look like a bell-shaped function. And the most value is the standard e to the power minus this. There's something else. Let's don't talk about something else. Let's just talking about a basic format. The basic format is this blue one. Blue one's value mainly from -1 to 1. Is that okay? It actually is a function that is from -1 to 1. Something outside it still have some value, but very few. This one is a probability distribution function. Okay? Any question? Anybody know what Gaussian function is for? Hello? Hello? Anybody know what is Gaussian function?
No.
No? No one? So that's when you take a SAT exam and the student score distribution may be looking like this. The mean value is right here, maybe 1300. And then some student higher score, something lower score, and the distribution usually is like a Gaussian distribution. So this Gaussian distribution is used in probability theory and also in statistics. Okay? Is that okay?
Yeah.
And anyway, right here we're talking about math, not just stats. So you want to calculate the Gaussian function. Okay, you want to calculate the Gaussian function, okay? You want to calculate the Gaussian function. So let's go back to our coding. So let's define the function. So the return value is a double type. And then the function name that's called Gaussian. So you will have double x and then integer n, go to the n terms, right? You go to the n term. Okay, that's actually get started from here, okay? So now let's go back to the problem statement, okay? So now, your Gaussian function is like this. It's a sum of the series, okay? So each term is the initial term is 1, second term is minus x squared, third term is x fourth divided by 2. Okay, and each term is actually -1 to the I times x 2I divided by I n. Okay, so this one is actually x 2 times 1 divided by 1. This term is actually x0 divided by 0 band. Okay, so this is 1, though that's no problem. Let's actually get started from there, okay? So we will actually define something called term. So initially the term would be equal to, so let's create a variable called term. Initial value is 1, right? So second term is minus s squared divided by 1. It is a 1. It is actually is 1 times times -1 times s squared divided by 1. This one is the iteration variable. This one is s squared. This one is -1. This one is the original term. Okay, let's assume this is called A0. This one is A1. So let's look at A2. A2 will be equal to, let me change the color, okay? So A2 will be equal to x4 divided by 2. It is this minus s squared divided by 1 times -1 times s squared divided by 2. So it is A1 times -1 times s squared divided by 2. So far, okay?
Yeah.
So every time, what do you get? You actually time this term. Every time we time this term, your original term times this, you will get the A2. Okay, that's what I get. And that's what the repetition will be. Okay. And based on what the repetition will be, you design your loop. Okay, you design your function in the loop based on that. So this one belongs to the loop processing, more advanced loop, but here we are talking about function, so we kind of discussed the previous chapter's homework, okay? It is a discussion for loop, but here we are talking about function, so we do this. Any questions so far?
No.
No? How about Harrison, are you okay?
Yeah.
Yeah? Okay, let's get started. If you have a question, you must ask, okay? How about Stephen, are you okay?
Yeah.
So we will have a double, let's call it sum as well. The sum equals 0.0. At the end, you will actually return the sum, okay? So let's actually create something called double A, okay, equals 1. This one, let's call it A, not A0, okay? Initial term, the first term, right? So you will do for loop, okay? Okay, you are up to the n terms, so you will do n time. Okay, you do n time. That's actually less than equals n. Okay, you will put n plus 1 time because you had a 0, 1, 2 up to x 2 n. Okay, this is x 2 times 0. So there is a n plus 1 term. Okay, so it's from 0 to n minus 1. So what you would do is actually you do what? You do A is your term, so your sum or plus equal your term. Right? Your next term will be your original term times -1 let's see, no, I'm sorry, okay. No, let's calculate the term first. Let's calculate the term first. Okay, here let's do this if I not equal 0. Okay, if I not equal 0, you will update the term. I equal 0, you will actually directly use 1. Okay, I not equal 0, your term will be a times this times x divided by your I. Okay, x are double, so I integer actually is fine. I equal 0, you don't do it. Okay, so it's okay. Okay, and then your sum will plus equals your term. Okay, so before we do that, let's do this. Okay, let's do let's print out the A and see what happened. Okay. Okay, let's do 1 and take x equals 1 and then print line. Okay, this one is for the function of 10. Okay, let's just print this one. Okay.
Well, Dr. Chang,
Hmm?
uh, is it like okay if you do like you start like as I equals 1 instead of checking if I is not equal to 0?
That's okay. I'm just talking about general case.
Okay.
I want to print out the first term as well. Okay. You move this out one outside, this is fine. You put the sum initially with 1, right? Instead of 0, that's actually fine. Okay, I'm just trying to give you the general case. Okay, let's see. The first term is 1, second term is minus s squared. S is 1, so it is actually, wait, let me go back to the formula. The first term is minus s squared. Okay, s squared is minus 1 squared divided by 1, that is minus 1. Okay, second term is actually plus x fourths divided by 2, so it's 0.5. Okay, third term is actually x6 divided by minus, and this one is 6, right? So it's minus 1/6. Is that okay? So this actually, I think it's okay. I think it's okay. Okay, this one's okay. This one's okay, so we don't print it. Okay, we don't print it. Now we do an experiment, and that is fine. Okay, but that's not our purpose. Okay, that's not our purpose. Let's do another thing. So what I will do is actually this. What I will do is like let's actually do this. Let's do double x equals minus 1.0, x less than 1.0 plus e minus 9, x plus equals 0.01. So this one give you 200 points, and then you actually give you 200 points. And then, so you get started from minus 1.0, right? Second point is minus 0.99, something like that, okay? Keep going until 1.0. Okay. Here is 1E9, okay, 1E9. So this number is slightly over, what is it, 1.000000001. Slightly over, because we want to stop at a 1.0, but you cannot do equal. Equals, you cannot check it, okay? You cannot say that's an equal. No, not equal, you cannot do that. You have to do this. Now, we got that, and then we are going to do this. We are going to do Gaussian, but we will printf. Printf what? Let's printf percentage 0.2 f percentage 0.8 f x slash print. Let's print the x and also x and Gaussian tag. Okay, let's keep this n as 10. Okay, let's see. So we got the tongue of the number from -1 to this. Let's save us. Okay, this is chapter 10. Let's save the chapter 10. This one, let's call it ocean that comma secondary value file. And let's go to the hard disk. Open the Gaussian file. We got it. Let's actually put the extra line. Let's call it X and Gaussian. Okay, select everything, and then insert the joy. We got a Gaussian distribution function. Is that okay? Hello? Is that okay?
Yeah.
But this one is not very pretty. Let's do it again. This one, don't say it. Let's go back. This one, not good. Let's actually put one more line. That's actually automatically print out the X and Gaussian. So let's do print line. Okay, this one is print S comma Gaussian. Okay, something like that. Okay, and let's don't go by 1.0. Let's go to master 2 to 2. And then this one, let's go by this. Okay, this is good enough. Let's do compile. So I make it a little bit wider, okay? A little bit wider from 2 to -2. Okay, done. Now open this Gaussian file. Excel again. Oh no, I'm sorry. I wrong it, right? But I haven't saved it yet. I forget. My save is using this one. Okay, let me save it. This one, let me close it. Okay, let's save it. Okay. Override it, yes. Okay, once it's done, let's say you open it again. Okay, and let's select it. I'm sorry. Okay, They are supposed to go down and then flat. But as you can see, over 2 it already pick up and diverge because X too big and your N is not going to knock it down. Your N is too small, it doesn't knock it down. It do not converge. Okay, so this algorithm is very tricky. It works, but your N must be big enough to make it work. So when you go to a very big number, the N will go to very big, and then big negative minus the big positive to make it flat. But it doesn't flat out right here. You already see it already peaking a little bit near to. If you continue, it might diverge, and then it's not what we wanted. So you need to keep your input range at around 1. Is that okay so far? Is that okay so far? If you don't think that you want to flat it out, okay, let's try the experiment. You want to flat it out. Then let's do one thing. Okay, let's do one thing right here. Let's go back. Let's don't use the 10. Let's use 100. Let's do 100 too much. Let's do 30. Okay, do 30. Okay, let's see the effect of the 30. Okay, done. Let's actually save it. Let me run it one more time. Okay, now let's save it. Okay, let's save it. This one I use a 30. Okay, done. That actually opened it. So this example teach you the function, how to design a function, also teach you how to test a numerical problem, okay? When you do AI, there are tons of the numerical problem you need to deal with. So let's look at it. It's still picking, but it's still picking, okay? It's still picking, but a little bit better now, but it's still picking here, okay? So this one is actually a numerical problem, okay? The higher N, the ratio of higher N, you actually find out, okay? And then if not, it actually will diverge sometime. Because you are going to do X 200, that X is very big, knocked down by 200 band. That actually is big number divided by big number. That actually very, very unstable. Okay, very, very unstable. But here just to show you an example of how to write a function. Okay, write a function and the loop. The loop itself, when you design the loop itself, you need to look at each iteration. What is the current term? I put the I equal 0 here just because I want to show you the term 0, how you deal with the term 0. So each term you add to the sum, each term you add to the sum, each term you add to the sum. But your term A0 and A1, what is the new multiplication factor you multiply it? You multiply, that's the term, that's this part that you would multiply. Then your loop will be very simple. Then your loop will be very simple. Some of you, I see some of you do 3 for loop. Inside the for loop, you do 3 for loop here. That's definitely wrong, okay? That's definitely wrong. Is that okay?
Yeah.
You should utilize the partition structure to make the code pretty simple. This is very simple, just 3 terms. If you don't utilize that, then you actually may do n-band by itself. That will waste a lot of time. Just calculating the n-band every time. 1 band, 2 band, 3 band, 4 band. You already waste a lot of time. We are basically calculating this minus x2 to the next one, minus 1 This is 4. Okay, this is 6. We are calculating from here to here. Okay, to get a different term. That's the important part when you do iteration. Okay. Okay, actually this one actually is doing for loop. Let's assume that you do recursion. You want to do this one in recursive format. Okay, let's do this. Let's do recursive format. Okay, I'm sorry. Let's don't carry the sum. Okay. Plus Okay. Okay, this one, if you do it recursive, your A0 is this one. You do get started from A1 up to AN. AN, you will return the term of this. Okay, and every time you return, you return term of this. Every time you pass the previous the term and then pass the term to the next one. Okay. So this one does actually call it Gaussian recursive version, Gaussian R. Okay. So here that's called Gaussian R. Let's see if it's the same. It's different. Okay, something wrong. Okay, something wrong here. So you get started with x equals 1 and initial term is you get it with 1. So your previous term is 1, so you pass the A0 to there. And then you time this. And you plus a term time this to there. Let me print out a term every time, okay? See what happened to the term. Another this one. You spend too much time. So you started from 1, and then you will go to n plus 1. Your term times your current I times 2x divided by I will be your an. Okay, you pass it to the next one. And you sum your original sum with this. So your A0 is 1.0. You actually go from 1 to n. Initial term is 1. Okay, I'll check this one later, okay? But anyway, you can come up with a recursive version, okay? I'll check with that later. Something is wrong. But what I want to say is that, well, no matter you do recursive version or regular version, or actually it's correct. That's 0.018. That actually change it to the R version and compare. Actually, it's the same already. Okay, I'm sorry. Actually, it's the same. The recursive version and the regular version is already the same. Okay, so this one show you how when it's recursive is done. Your current version pass down the value to the next term. You do it recursively. And this is also a functional design, okay? It's also a functional design. But right now, we are not teaching you how to do recursive yet, just telling you what recursion is, okay? But if you do the loop design, you need to consider the previous iteration and current iterations relationship and update your term every time. That's what I want to say today, okay? And recursive design is similar, okay? So this one R or no R, you get the same result, okay? Let's go back to the slides. Let me finish up the chapter first, and then let's see. Any questions so far?
No.
No? Okay. So now here we actually finish all of the main topic for the functional programming, okay? And then at the very end of the chapter, we do cover the character, random character that we covered already. And this scope of the local variable, we talked about it already, okay? This local variable, we talked about it already. Let's talk about this overloading of the functions, okay? Overloading of the functions. So what is overloading? That's what we want to say. So let's assume that we actually have a function that calculates the maximum. Okay, so let's do this. Let's do public static, okay, integer maximum, integer x, and integer y. Okay. So if x greater equals y, return x, otherwise return y. Okay. So this one is the maximum function. But here, can I define this? Can I define public static integer maximum, integer a, and integer b? Is that okay? It's not okay. It's not okay because this part we talk about it actually is called master signature. They don't test the variable name, they test the type. As long as the integer and the integer is the same type, we are considering these two are the same function. So they are the same function. So here you do have, you say it already defined in the class. So this is not allowed. You have to change the name to the maximum two. Is that okay? You cannot use the same name. Use the same name, they are considered to be the same function. Is that okay?
Yeah.
Hello? But if I do this, if I do public static double, maximum double x double y, everything the same. And is this okay? This is okay. This we call it overload. Overloading what? Overloading the function name. If this is a maximum, a function that can deal with integer, also a function that can deal with double. That's called overloading. It's okay?
Yeah.
Okay, now, if I have a maximum 3, 4, then this one definitely will call this function because it's integer, right? But if here I put the 3.0, what will happen? It will call this function, it will not call this function because 3.0 is not compatible with this. It will definitely call this function. Is that okay? Hello, is that okay? If I don't have this, if I don't have this double function, I just have the integer function, then you will have the type mismatch problem because you will pass a double to a integer. That's wrong. Okay, that's also wrong. Okay, so these are something you need to know. Very important. Okay, overloading of the functions. Okay, that's what I want to cover for the overloading. Other than that should be fine. Okay, other than that should be fine. Any questions so far?
No.
Okay, so we are almost 10 o'clock. Next time, if I have time, I'll go over this exercise 1 as well, but not today, okay? I'll go over this one as well, but not today. We don't have enough time. Okay, but look into this one, okay, making sure you understand it, okay? It's a very important exercise. This one actually is from a textbook, the Think Java textbook, okay? It's not really that hard. Think Java 2.0, we actually take the problem from that textbook, okay? So really understand this problem and go over some of you do operate a function, but you do not go through here, really into the look at the Gaussian distribution feature. Okay, some of you just do Gaussian, maybe 2 and then 5. You just write a function. I know you write a function, and I know you don't understand what this one is. Okay, some even do Gaussian 10, 4. That's totally out of the range that we are looking for. Okay, but it's okay. I know you don't understand what is Gaussian. Here, just exercise, not only exercise the Gaussian function, but also sometimes you need to understand the problem. Okay, so let me repeat again. When you do coding, there's level 1. You learn the programming language. Level 2, you go to coding back, you learn the program structure. Right? Level 3, you learn data structure and computing algorithm, DSA, okay. But that's not enough. There's still another level up, that's problem solving. Solve your calculus, solve your Taylor's expansion, solve your probability distribution problem. You are a computer scientist. You need to learn everything here, okay? Not just the language, not just the program structure, not just the algorithm, but you also need to solve the problem. Okay, that's what we are keep teaching you, the different levels of the skills. Right here, not only you need to write the function, you must also know what is Gaussian. Okay, that's the purpose, okay? Okay, if no question, that's it for today, okay? And then remember that this week you have an extra exercise. You need to finish the midterm part, okay? It'll take you another 1.5 hours to do it. It's in the middle of chapter 9 and 10, okay? There's a midterm right here, okay? Okay, if no question, that's it for today, okay? Good night and bye-bye.
Bye, thank you.
Bye-bye.
Thank you.